for isolated group. Now, what is NC, NQ, and gamma? There is one table which is given NC, NQ, and gamma, that is the Terzaghi's bearing capacity factors. These NC, NQ, and gamma are the Terzaghi's bearing capacity factors where it depends upon the value of 1, right? So here NC, NQ, and gamma, Terzaghi's bearing capacity factors depends upon phi value. Depends upon phi value. So some of the parameters that I will give it to you. So just many times in the examination, directly the NC, NQ, and gamma is given, or the value for the different phi values are given. So here I just write down phi, then it will be NC, NQ, and gamma. So this table may be given in the examination, and if table is not given directly, the values may be given. So if the y value is 0, then NC is so it will be, suppose this is 10, it will be 9.6, then it is 2.7, 1.2, then if it is 50 degree, it will be 12.9, 4.4, 2.5. Then when it is 20 degree, it is 17.7, 7.4 and 5.0. Then if there is a 25, then it will be 25.1, 12.7 and 9.7. And for 0, this is the spatial case when the phi is 0. When this is the spatial case when phi equal to 0, when the soil is pure clay. When the soil is pure clay, when phi is equal to 0, if phi is equal to 0, it will be taken as 5.7. Then here, this NC is taken as 5.7. NQ is taken as 1 and N gamma is taken as 0. So this is the special case of the pure cohesive soils. Actually, Divyam, see, this table is a standard table, right? This table is a standard table which will be applicable for all the cases of Terzaghi's bearing capacity theory. Then there are different theories also. There is a Merox theory, then there is a Skempton's theory, Srinivasan theory. So number of theories are there, and according to the theories, these parameters are modified. But the basic theory which is in your syllabus is Terzaghi's bearing capacity theory, and we are concerned about the Terzaghi's bearing capacity theory, and then all these values are constant. This is the table which is given in the book also. You have to refer this table. And if suppose the table is not given in the examination, directly the value of NC, NQ, N gamma for a particular table is given, right? So just write down all this, because many times the phi values and the NC and Q and N gamma values are not given, and in that case you have to given a table. Many times you have to modify this for the local shear failure condition. So we are talking and we are concerned about the local, general shear failure when there is a all conditions are in the ideal condition. Now this is an important thing. When the soil is a pure clay soil, when the soil is pure clay soil, ultimately the value of phi we are taking it as 0. When it is 0, AC is directly taken as 5.7, N2 is 1 and N gamma is 0. So this is the standard equation where the soil is considered to be the clay. Is it over? Now we will just switch over to the another place, right? So this is the simple thing that we have already discussed, right? Now, if the soil is a pure clay, right? I think this part is over. So I just rub this. Now, see, this is the case when soil is pure clay. Soil is pure clay. So I will just consider these split footing cases for all the cases for split footing. If soil is pure clay, so naturally the value of phi is equal to 0. So here this value of phi is equal to 0. If value of phi is equal to 0, then NC is taken as 5.7, NQ is taken as 1 and N gamma is taken as 0. Now we will just consider the case of a split footing, right? So here we will just consider split footing. If suppose this is the split footing, so naturally the equation is 1, that is CNC plus QNP plus 0.5 V into gamma into N gamma. So here we will just consider this QU is equal to CNC plus QNQ plus 0.5 V into gamma into N gamma, right? This is the equation. Now, as the soil is pure clay, phi value is 0 and therefore the NC is found to be 5.7, NQ is 1 and N gamma is 0. Here, this N gamma value is 0, therefore this whole term will be 0 in the equation of clay, right? Then this NQ is considered to be the 1. So what is the equation? And NC is taken as 5.7. So here the equation becomes Q is equal to 5.7 C plus Q only. And what is Q? Q is equal to gamma into D. So this is the equation for split footing if there is a pure clay. Is it clear? This is the equation when the soil is a pure clay. This NC is 5.7 and NQ is 1 and N gamma is 0. As N gamma is 0, the whole equation is 0. The whole term is 0. That is the foundation soil term is 0. NQ is 1, therefore only the Q part is there and this Q is equal to gamma into dr. Then NC is taken as 5.7. Is it clear to all? Then the another case when the soil is pure sand. Soil is sandy soil. Soil is sandy soil. If the soil is a pure sand, then which value is taken as 0? In such cases, the value of C, that is cohesion, is equal to 0. And if cohesion is not there, in that case, the first term will be 0, and therefore the equation for split footing is split footing is equal to QU CNC plus QNQ plus 0.5 V into gamma into N gamma. So as this term is 0, as C is 0, and therefore the equation QU is equal to Q into NQ plus 0.5 V into gamma into NQ. Is it clear to all? So this is the equation. The first equation that is considered to be the generalized equation for all the soil conditions, whether the soil is a sea soil, C5 soil. Yes, so cohesion and friction both are present over there. Then the soil is pure clay. Then the NC is 5.7, N2 is 1, and therefore the equation at the last will be 5.7. C gamma into df. When there is a pure sandy soil, cohesion value is 0. In that case, the equation, the first term will be cancelled, and here it will be Q plus 0.5 D into gamma into N gamma. Is there any doubt in this? I think there will not be any doubt in this. Then the next term is once you get the value of QU, then how you will find out the QU net? It will be QU net is equal to QU minus gamma into df. QU net is equal to QU minus gamma into df. Then how you will get Q set? How you get Q set? Q set is equal to QU minus gamma into df upon factor of safety plus gamma into df. So this part we have already discussed, still I just wanted to revise it. Right? So is it clear? Now come to the local shear failure condition. Come to the local shear failure. So in this case, we will assume that there is a local shear failure. When we will say that the condition is a local shear failure, there are certain things which are given. When phi is greater than 36 degree, it is considered to be the general shear failure. When phi is less than 28 degree, then it will be considered as local shear failure. And when the phi is in between 28 to 36, it is considered as mixed failure. Now, we will just assume that there is a local shear failure. When there is a local shear failure, we are modifying the two terms, that is C is becomes Cm. C is becomes Cm. Here, what is Cm? Cm is equal to 2/3 of C. And phi is becomes phi m. Phi is becomes phi m. Where what is phi m? Phi m is equal to tan inverse of 2/3 of tan phi. 2/3 of tan phi. Once you get the value of phi m, then the corresponding value of NC dash, NQ dash, and N gamma dash for modified phi. Right? So this is the cases which we are taken into consideration and for which we are then consider the equation. So is it clear to all? Just tell me whether it will be clear to all. Can we proceed for the numericals? Anyone else? Rajveer? Karthik? सबको समझ?
Yes, ma'am.
आदित्य? वही चेहरे आते हैं. अभिजीत? वही लोग रिस्पॉन्ड करते हैं. I just want to answer from the another students. Ayush, Jigyasa, Rajveer, very good. Okay. So we will start the numerical. We will first take the numerical where we are considering a local shear failure case. Right? Write down. A square footing, numerical लिखो, a square footing 1.3 meter by 1.3 meter, a square footing 1.3 meter by 1.3 meter is founded at a depth of 1.2 meter below ground level The soil properties are C is equal to 20. C is equal to 20 kilonewton per meter square. Phi is 22. Phi is 22. Gamma is 18 kilonewton. Gamma is 18 kilonewton per meter cube. To stop. Local shear failure is expected to occur. Local shear failure is expected to occur at a site. Determine net ultimate bearing capacity. Determine net ultimate bearing capacity and SBC of soil. Right? I think everyone has data for the NC, NQ and gamma values, right? Because here the phi is given as 22 and C is given as 20, I think. C is given as 20 and phi is given as 22. So in this case, as phi is less than 22 degree, therefore we have to modify it because it is a case of local shear failure, right? So I'll just write the equation over here. And one thing you always remember while solving the numericals for this, you always remember that you have to draw a proper diagram of it. So what is the condition? If footing is given as a square footing, so here this is the base. And just to draw a plan of this. As it is a square footing, so B is given. So what is this B? B is given as 1.3. Here also, this B is given as 1.3. So this is the plan and this is the section. Right? What is the depth? Depth is given as 1.3. F is given as 1.2. The density of the soil, that is Q, is equal to gamma into dA. Q is equal to gamma into dA. So this much is the soil condition. These are the soil conditions are given. What is the value of C? Phi is given as 22 degree and C is given as 20. Right? So at this stage, we don't know anything about the soil type, and here the gamma is considered to be the 18 kilonewton per meter cube. C is kilonewton per meter square. So this is the data given. Now in this case, what is the value of phi? As phi is less than 28 degrees. Therefore, local shear failure. Which type of failure is expected to come? There is a case of local shear failure. शायद तुम लोगों को टेढ़ा दिख रहा है ना? So phi is less than 28 degrees. So it is the case of what? It is the case of local shear failure. And if there is a local shear failure, phi and C has to be modified. Cm and phi m you have to find. Right? So what is Cm? Cm is equal to 2/3 of, what is the value of C? C is 20. Naturally, it has to be the reduced value we have to taken into consideration. Reduced value means जनरल शेयर फेल्यूर के लिए हम आइडियल कंडीशंस अज्यूम करके चल रहे हैं, वो आइडियल कंडीशंस आपका लोकल शेयर फेल्यूर में नहीं है, इसीलिए हमको जो गिवन वैल्यूज है उसको रिड्यूस करना है। एंड कितना रिड्यूस करना है? 63 दिस 66% लेना है, 33% को रिड्यूस करना है। सो इट इज 2/3 ऑफ C, then Ym is equal to tan inverse of 2/3 of tan, what is the value of that? 2/3, 20. So Cm is becomes 13.20 and Ym is 15. 13.3 kilonewton per meter square, and this is found to be 15. Now, if the value directly it comes 15, if it is not 15, sometime it may be 13 is given, and you are having the table for 10 and 15. आपके लिए 10 5 10 के लिए values है और 5 15 के लिए value है, and if you found the value of Ym is suppose 13, in that case you have to interpolate the value of NC, NQ and gamma, right? So here directly the value of 15 is obtained, and you all are having the table now, which is I have given you in the previous topic, that is NC, NQ and gamma, all the values for 15 is directly given. If it is not, suppose here the 15 की जगह आपका 13 आना है, so in that case you have to interpolate it for the 10 and 15. So तीनों के लिए आपको इंटरपोलेशन करके NC डैश, NQ डैश और N gamma डैश मिलेगा। अभी यहाँ पर हमारे लिए डायरेक्टली वैल्यू फॉर 15 इट इज अवेलेबल, सो आई विल जस्ट टेक दिस वैल्यू ऑफ NC डैश फॉर 15 फॉर Ym is equal to 15. Directly the NC dash is given as 12.9, NQ dash is given as 4.4, and N gamma dash is given as 2.5. So these are the directly which we will just have a table, and from that table you can directly take this value. Now this is NC dash, NQ dash. Now again one more thing which is given. Which type of foundation is this? This is a square footing. So as it is a square footing, what is the equation? Square footing. What is the equation for this? There is QU is equal to 1.3 CNC plus gamma into BF NQ plus, instead of 0.5 now there is 0.4 B into gamma into N gamma. So all these are the dash value because these we have considered from the, यहाँ पर देखो, just remember this. In this equation, you have to consider the value for Cm, that is the modified cohesion, then NC dash, then NQ dash, and N gamma dash. So this is the equation for the square footing or local shear failure. For the local shear failure. Now, once you get these values, you have to put the value of Q net, and that is Q2 minus gamma into DF. Assume factor of safety, assume factor of safety is 3. Assume factor of safety of 3. Just calculate it and tell me what is the value of QU. Just put it into the text box. So here, this QU is now QU is equal to 1.3 into C is 13.2 into NC is 12.9, then plus gamma is 80 into 1.2 into NQ is 4.4 plus 0.4 into D is 1.3, gamma is 18 and N gamma is 2.5. And you just always remember that more is the value of phi, the numerical value of NC, NQ and gamma is more, and if this NC, NQ and gamma is more, ultimately all this NC, NQ and gamma are in multiplication. So ultimately, when the soil is having more phi value, means soil becomes more compact, then the value of phi will be more. If phi is more, these NC, NQ and gamma will be more, and directly the equation will be the bearing capacity will be more. So just find out the value of QU. In this, which modifications you have to make? This is the most important modification, that is CM. And this is one more, instead of 0.5, whether it is in the strip footing, it is 0.5. So in the square footing, it is found to be 0.4. Right? Then the value is obtained to be how much value? Anybody is having the answer? It is found to be 320.38. It is 341. It is 341.98. Q is 341.98. You can just round it as 342. It is 342 kilonewton per meter square. Always remember that. What will be the unit? Unit is always in where there is a strip footing. The unit is kilonewton per meter run. But here it is a square footing, isolated footing. So unit is 342 kilonewton per meter square. Right? So then we just find out Q safe is equal to 342 minus 80 into 1.2 divided by factor of safety is 3 plus 18 into 1.2. 18 into 1.2. So what is the value of Q safe? So in this case, this Q safe is equal to whatever is the value. Just find out. It is 128.4. इतना कम नहीं आएगा. Okay, whatever is the value. सभी को इतना ही आ रहा है. 128.4. Okay, whatever. 128.4 kilonewton per meter square. So write down the next numerical. Write down. A circular footing of 1.5 meter diameter. A circular footing of 1.5 meter diameter is founded at a depth of 1.6 meter below ground level. 1.6 meter below ground level. Meter below ground level. The soil properties are equal to 15 kilonewton per meter square. C is equal to 15 kilonewton per meter square. And angle of friction is 37 degree. And angle of friction is 37 degree. Compute the SBC of soil. Compute the SBC of soil by taking factor of safety is 3. By taking factor of safety is 3. For phi is 37 degree. For phi is 37 degree. NC is 70. NQ is 65. NC is 70. NQ is 65. And N gamma is 70. N gamma is 70. Now what is given in the numerical? As the phi is given as 37 degree, means it is more than 36 degree, means it is the case of general shear failure, no need to modify the value of C and phi, right? So, and instead of a square footing, the footing is given as a circular footing. So, what changes you have to make into the equation? In the equation, you have to, I'll just write the equation. So here, this is a circular footing. This is, the depth is 1.6 meter from the ground level. Then the footing is a circular footing. So as this is a circular footing, what is the diameter? Diameter is given as 1.5. So this is also 1.5. Then the value of C is given as 50 and here phi is given as 37. Again, gamma is taken as suppose 16.5 kilonewton per meter. Then the factor of safety is given as 3. So this much data is given. Now, just the footing is a circular footing. Circular footing. So what is the equation of circular footing? Circular footing QU is equal to 1.3 CNC plus QN2 plus 0.3. 0.3. This 0.3 T into gamma into N gamma. Now always remember that in the strip footing in the equation there is 0.5. Then the equation of square footing it is 0.4 and in the equation of circular footing it is 0.3. Always remember that the footing, the value of load carrying capacity for a circular footing is always value. Always remember that in circular footing the ultimate bearing capacity always less because the multiplication factor is reduced than 0.1, right? And it is in multiplication, therefore over the field circular footing is never suggested to use because the load carrying capacity of a circular footing is always less as the multiplication factor is 0.3, whereas in square footing it is 0.4, in rectangular it is in strip footing it is 0.5, right? So this is the one case, and in the another one, if footing is twice greater than 36 degree, means it is the case of general shear failure. It is the case of general shear failure, means no need to modify the equations. So directly the value of QU is equal to 1.3. Then it will be 50. What is the value of NC is given? NC is given as 70 plus gamma is 1.6 and gamma is 16.5 and gamma is given as 65 plus 0.3 into 1.5, 16.5, and n gamma is again 7. So find out the value of Q. Once you get the value of Q, find out the value of Q net, or directly I will just find out Q set. And you can do one thing. You can do one thing. You can find out the same with the same data. You assume there is a square footing and check what is the change in the bearing capacity, right? So let's write down. Next, Divyam, it is 272.5 and Arundhati it is 36232. बहुत ज्यादा डिफरेंस है, एक बार चेक करो क्या गलत हुआ है. दोनों के इक्वेशन में बहुत ज्यादा गलत है. प्रणय, it is 3600. Okay, just check it and find out. Write down next equation. A strip footing is 2 meter wide. A strip footing is 2 meter wide and placed at a depth of 2 meter below ground level. Full stop. Soil has a unit weight of 15 kilonewton per meter cube. Soil has a unit weight of 15 kilonewton per meter cube. Cohesion is 8 kilonewton per meter square. Cohesion 8 kilonewton per meter square. And angle of friction is 36 degree. Compute the SBC of soil. By taking factor of safety of 3. For phi is 36 degree. NC is 60. NQ is 56. And N gamma is 68. N gamma is 68. So what are the changes you have to make? No case of local shear failure because phi is 36 degree means it is the case of general shear failure, and footing is considered to be the strip footing. So what will be the equation? It will be CNC plus QNQ plus 0.5 B into gamma into N gamma. So it is a very simple type of problem, right? Then write down the next. You just write down it, try to solve it. Otherwise we will solve it over here. Determine the size of the square footing. To carry a safe load of 900 kilonewton with depth of foundation as 1.2 meter. Cohesion is 20 kilonewton per meter square. gamma is 20 kilonewton per meter cube. Gamma is 20 kilonewton per meter cube. Assume general shear failure. Assume general shear failure with bearing capacity factors. With bearing capacity factors, NC is 64. NC is 64. NQ is 80. And N gamma is 96. The values are given over here: 60, 80, and 96. NC is 64, NQ is 80, and NC is 96. Okay. So in this case, you have to go reverse. आपको reverse जाना है. First, you have to find out the Q ultimate, and then you have to go for the further equation. In this case, you have to find out the value of B. As it is a square footing, first you will get the value of A, area, and what is the area of the square footing? It will be B square, right? So the problem is simple. Just try to do it, otherwise we will solve it over here, right? One more thing. Again, Wednesday there will be a holiday. तो वेडनेसडे का क्लास पॉसिबल नहीं है, तो आज आपका एक एक्स्ट्रा क्लास हो सकता है क्या? कुछ अभी आपका प्रैक्टिकल है, कितने बजे तक है? 12:51 को, ठीक है। तुम लोग बताओ फिर आज या कल में कब लेना है, तो क्योंकि पहले भी 1-2 क्लासेस गए हैं, तो एक क्लास लेके अपन वाटर टेबल, इसमें अभी वाटर टेबल इफेक्ट भी आता है, तो दैट वी विल कवर, राइट? इज इट ओके? ओके ओके, डिसाइड करो एंड लेट मी नो, राइट? लीव करो अभी।